Okay, welcome back to the chemistry lesson. Okay, teacher Jerry here. So today in this video, I'm going to look at rate of reactions. Basically, two parts. The second part will be more on the graph, right? How we interpret graph, what I think we look out for graph. Okay, let's go on to the first part first. Um, the big picture of speed of reaction is that, how can we increase speed? What are the factors that will affect speed, right? Then how do we interpret into the data? Right, it's just like when we want to learn something, we may also want to take time to check in what are the factors that help us to learn better, faster. We should also be exploring not only just how much we learn, but how fast we can learn. What is the maximum? How much we can cover? All right, not necessarily everything. Okay, so the first part is very simple. All right, we need to learn how to measure speed of reaction. So you can see from these two setups, there are two setups that we need to learn how to draw. Okay, but one thing is for sure, right? Our speed of reaction, right, definitely involve gas, produce of gas, right? Okay, in our syllabus. Okay, so we measure the volume of gas using the gas range. We can, and then there's a mass loss here is also due to the gas, right? Because the gas escape, right? The cotton wool actually does not prevent gas from escaping, unless you are saying that putting cotton wool at your nose will suffocate you to death. Obviously not. All right. So it's more of preventing the acid from spraying, right? To spray loss. So that every mass loss is due to the gas escape, not because of acid spilling out of the conical flask, especially when the reaction is quite fast in the beginning, right? Okay, so in a balanced equation, like calcium carbonate, okay, plus hydrochloric acid, by right, in the balanced equation, whatever I have on left hand side must be on the right hand side. So by right, the mass should be the same because this mass is the total mass of the reacting mixture that include the reactants and the products. But if this gas escape, then of course after reaction it will appear to be slightly lesser, right? So depending, you can see that the x-axis will be time, but important thing is the y-axis because if I put mass loss here, okay, then the graph will be looking like this. So it depends on what we want to put at the y-axis and what do we measure, right? So this is how we measure the speed of reaction. And when we plot the graph, important thing is that the gradient tells us the speed of reaction, right? So we can see that the gradient, okay, whether, right, whether it's this kind of shape or this kind of shape, right? The gradient will tell us speed. Okay, so basically, which gradient means steeper, faster. And you can see that you always have three things, okay, quite similar no matter what the shape. So the reaction will be the fastest at the beginning, right? Steepest at the beginning because you got the most maximum reactant. Then your reaction will start to slow down as the reactant starts to use up and finally come to a stop, right? So even this kind of shape, same thing, fastest at the beginning and then slowing down because becoming more gentle and then finally stop when it becomes horizontal because all the reactants use up. Right, this is the general 3 points that we can see in any graph. All right, and definitely in nature, the speed would not be constant. All right, so now we need to look at what are the four factors, or for the pure chem, five factors that will affect speed. So we need to understand first thing, they like to talk about collision theory. So you must be collision in order for reaction to happen. Right, it's just like for a boy and girl to get in a relationship, they definitely must get to know each other, whether through a mutual friend, whether through a platform, apps, whether it's a virtual e-meet or whatever, they must got to know each other because if they don't meet each other, they will never even have a chance to start a relationship. But we also understand that not all collisions will lead to reaction. Okay, doesn't mean a person go for matchmaking means confirm guarantee plus chop will get married or will even get a relationship. Right? So we talk about effective collision. So important thing is that we must talk about effective collisions. And why are collision effective? Why are some are not? All right. Basically, when they collide at different angle because the molecules are in random motions. Right. Just imagine if you bump into your friend head on or at the side, the energy you get is different. So different bond got different bond energy. We talk about activation energy in energetics. If you forgot, you can take a look. So activation energy is the minimum amount of energy needed to break the bonds. So different bonds got different energy. So when they collide, they will give out energy to break the bond. If the energy is enough to break the bond, then it's successful, effective. It will go on to reaction. But if they collide, the energy given out is less than the bond energy needed to break the bond, right? Then of course no reaction will happen. So we can see on the graph, I mentioned already, there are always three things, right? Fastest at the beginning, okay, then slow down with time, and then come to a stop when the reactant is used up. All right. Of course, in overall, you can know that general the speed of reaction will slow down with time. All right. So these are the four factors. Okay, temperature, particle size, concentration, pressure. Okay, do take note. Okay, for pure chem, there's one more catalyst. So catalyst, I'll emphasize it is more for the pure chem. And of course, this is only for the O-level chem. The N-level chem students do not need to know reaction rate. It's not in your, it's not, it's not needed at all. Take note of the states. And we're talking about the reactants. So temperature is all states, right? You increase. Why? Because you see, you gain more energy. And you can see that that is a standard, right? They will say that this will increase the frequency. This is always the standard part, right? You can see now this will increase the frequency of the effective collision and increase the rate of reaction. So important thing is the effective collision, right? Not just collision. Okay, because with increased collision, you go for more matchmaking, doesn't mean that you go into reaction. Right? Just the first part is different. So we need to know that, like, for example, particle size only for solid, because only solid you can break them into small particle size. It's just like cooking, right? You cut a big piece of meat into smaller pieces. So there's more surface area. There are more surface area exposed. Then for concentration, it's only for aqueous, which is very common because most of our reactant chemical reagent in the lab are in solution. So equals means more per dm cube. So be careful is that there is it must be per unit volume. Okay, because more particles doesn't always mean that there's more collision. Because if the volume increase, then of course the collision, it doesn't mean they're close together. And pressure is something similar to concentration, but pressure only for gas for some very simple reason. We cannot compress solid, liquid, or aqueous. We can only compress gas. But concentration and pressure has a similar meaning, whether you add more particles in per unit volume or the particles stay the same, you decrease the volume, because compress means increase pressure, right? There will always be more reacting particles per unit volume. Okay, that means in both cases, the particles are closer together, and therefore you increase the frequency of effective collision and the speed of reaction increase. Right, so it's very standard. Right, all has this will increase the frequency of effective collision and the rate of reaction. Only at the starting part we need to explain why this will increase the effective collision. All right, and then last but not least, for the catalyst, okay, for the pure chem students. All right, now remember that catalyst is very specific, just like enzymes. Okay, but catalyst basically what happens is that you provide alternate pathway of lower activation energy. So for example, you go from point A to point B. If the highway is jammed, all right, then you can take a smaller path. So the catalyst provide a smaller path, right? I mean the road that's less jammed, and then you still reach the same destination, right? So this also remind us that to success, it's not only one way. There are many, many different ways, right? It depends on who. Sometimes the people whom we meet, the opportunity that we have are like catalysts, right? That they can help us to speed up the process. Right, so technically, yes, okay, when we lower activation energy means we increase, okay, that means there will be more particles. Right, for example, if now A1 is from 75 to 70, the test score of the students still the same. But if I reduce the benchmark of A1 from 75 to 70, that means more students will get A1. So more students will get into reaction. All right. And catalysts are chemically unchanged. So that means they can be reused. You don't need to like have plenty of them. They can be chemically reused. And you realize that catalysts are normally transition matter or products of transition matter. All right. So this will be the main one that help us to explain, interpret graph, understand how to draw how to set up to measure speed, and of course, understanding how to explain what are the factors that affect. Right? Look at video 2 for how do we interpret graph. Okay, for the second part of this speed of reaction. Thank you.